everyone, welcome back for another deep dive. Today we're getting into something that seems deceptively simple at first, but it's actually way more complex than you might think. Industrial flame detection.
Yeah, you think fire, you think alarm, sounds pretty straightforward.
Yeah.
But in reality,
It's a whole other ballgame.
it really is.
We're talking about systems designed to work in high pressure situations where even a few seconds can make the difference between a small incident and, well, a total catastrophe.
Exactly. And it's not just about protecting people, though obviously that's the top priority. It's also about safeguarding these huge industrial facilities, right? You got to think about preventing downtime, minimizing environmental impacts, all that. A really well-designed flame detection system, that's not an option. It's a necessity if you're dealing with anything flammable.
Totally. So let's say you're tasked with designing one of these systems. Where do you even start? I mean, our source material really dug into the design requirements, and it looks like step one is hazard analysis. What does that actually involve when we're talking specifically about flame detection?
So it boils down to this. You have to figure out the exact risks in that specific facility. Like, what are they working with? What's flammable? Are there open flames as part of the process? Where are those ignition sources, the things that could actually start a fire? And then thinking about the consequences, where would a fire cause the most damage, either to the people working there or to the equipment? It's kind of like putting a puzzle together to pinpoint the weak points, the places that are most vulnerable.
Gotcha. So it's more than just like putting a detector on every wall and hoping for the best.
Way more. You got to think about the layout of the whole place, how air flows through the building, even stuff like fire pathways. Like if a fire starts here, how is it going to spread based on, walls, doorways, all that. This analysis, it's literally the foundation for the entire system.
Okay, that makes sense. So you figured out your hazards. What's flammable? Where are the riskiest spots? What's next? How do you actually go from that analysis to building a system?
That's where you get into the nitty-gritty of choosing the right flame detection technology. And this is where it gets really interesting, because there's no one-size-fits-all solution. Different types of fires need different detection methods.
So you're customizing these systems based on the specific fuels and hazards they might encounter. Tell me more about that.
Exactly. For example, picture a gasoline fire. Big, bright, lots of light, right? Burns really differently from, say, a natural gas fire, which might not be as visible but throws off a ton of heat, especially in certain infrared wavelengths.
So you need a detector that's tuned into the specific type of fire it's looking for.
You got it. It's all about recognizing the unique signature of each fuel type. That's why there's a whole range of different flame detection technologies, each with its own pros and cons. Like, you've got ultraviolet detectors, super sensitive to the light from a flame. They're great for fast-burning fires really quick.
Those are the ones that react almost instantly, right? Like at the speed of light, literally.
That's the one. But there's a trade-off. They can be a little, shall we say, enthusiastic, prone to false alarms from things like, a welding arc or even a lightning storm.
Oh, wow.
Then on the other hand, you've got your infrared detectors. They're focused on the heat signature, not so much the light. Less likely to be fooled by a stray spark, but they might be a tad slower to react.
So it's a balancing act, speed versus accuracy, depending on what you're trying to protect. But it sounds like you don't always have to choose just one, right? Our source talked about using multiple technologies together. What's the advantage of that?
That's the beauty of a layered approach.
Yeah.
By combining different detector types, you're essentially creating a safety net with, multiple layers. It's much less likely to miss a fire and much harder to fool with a false alarm.
So it's not enough to just have detectors scattered around. It's about them working together as a system, right? Like, we're talking about more than just a simple fire alarm here. This is a whole network.
Exactly. And that's where those design requirements we talked about come in. Making sure those detectors are in the right place, calibrated for the right things, and all hooked into a system that can actually respond effectively.
So we've got our detectors all set up, strategically placed, ready to go. But like any technology, I imagine even the best detectors are only as good as their performance, right? What are some of the things that determine how well a flame detection system actually works out in the real world?
That's the key question, isn't it? It's one thing to have the technology, but making sure it actually delivers when it counts, that's crucial. And our source highlighted a few key performance factors. One that really jumped out was this idea of false alarm immunity.
Right, because a system that's constantly going off for no reason, that's not just annoying, it's dangerous, people start ignoring it, or it slows down the response when there's a real fire.
Exactly. And minimizing those false alarms, That takes some pretty sophisticated technology. Like nowadays, a lot of these detectors use something called spectral analysis to tell the difference between an actual flame and, some other source of light or radiation.
Spectral analysis, huh? That sounds intense. So is that like giving the detector a prism to break down the light and look for like a fire's fingerprint?
That's a great way to think about it. Yeah, every type of fire, it gives off a unique spectrum of light. And these detectors, they can analyze that spectrum, compare it to a library of known fire signatures, and figure out, is this the real deal? Or is it just a reflection off something shiny or, a welding arc across the room?
Wow, so it's like a built-in lie detector test for
Yeah.
fires. That's really neat. Okay, what else? Our source also mentioned detection range as being super important. I mean, obviously you want a system that can see a fire from a safe distance, but why is getting that range right so important?
Think about it like this. A small fire, if you catch it early, you can often put it out quickly. Minimal damage, right?
Why?
But if it's allowed to grow and grow undetected, it can turn into something much bigger, much more dangerous, much more destructive very quickly.
Right, right.
Having that wide detection range, it's all about early detection. It gives you that critical head start. You can respond before things get out of control.
So every second counts. And speaking of time, that leads us to another factor our source brought up, response time. I'm guessing in an industrial setting, we're not talking about minutes or even seconds here, right? We're talking milliseconds.
You got it. When it comes to fire, every millisecond matters. And the kind of detection technology you use, that plays a huge role in how fast the system can react. Like we were saying before, those ultraviolet detectors, they're incredibly fast because they're basically responding to the speed of light.
Right. Light travels faster than heat, so it makes sense that those UV detectors would have the edge there. But what about the infrared ones, the ones that rely on heat signatures? Are those still effective even if they're a bit slower?
Absolutely. They may not be quite as lightning fast, but they still have really impressive response times. And remember, they have their own advantages, like not being as easily fooled by smoke or anything obscuring the view. It really depends on what you're trying to protect and what the environment's like.
Right, so it's about choosing the right tool for the job, finding that balance between speed, accuracy, and reliability. Okay, so we've got false alarm immunity, detection range, response time, all super important. Anything else?
One more big one.
Okay.
Our source called it field of view.
Field of view, okay. What does that mean when we're talking about flame detection?
It's kind of like, imagine each detector has its own cone of vision, like a security camera. The field of view is basically how much that detector can actually see within that cone. Because it's not enough to just have a detector that can see a mile away if it's pointed in the wrong direction or if there's something blocking its view.
Ah, so placement is just as important as the tech itself.
Yeah.
You have to make sure those cones of vision, those fields of view, are covering all the important areas.
Exactly. And that's another reason why that hazard analysis we talked about earlier, that's so important. You got to understand the layout, the potential fire pathways, all that, to figure out where those detectors will be most effective.
It's like a giant game of chess, but instead of protecting your king, you're protecting an entire facility.
Exactly. There's a lot more strategy to it than people might realize. But here's the thing. It's not just about the technology and where you put it. There are all these other factors, things that can affect how well a system performs, even if the detectors themselves are top of the line. Like a factory floor, that's not a sterile lab environment.
Right. It's messy. Things change. There's always something going on.
Exactly. And that's what our source called performance considerations.
Yeah.
All those real-world factors that can make or break a system.
So we're back talking about those real-world performance considerations that can make all the difference when it comes to flame detection. Like, even with the best tech, you still need to make sure it's actually going to work in a real-life situation, right?
It is. It's like, you could have the most amazing oven in the world, but if you don't know the right temperature, you're not baking a very good cake.
Perfect analogy. And speaking of getting things right, our source really stressed knowing the exact fuel types and fire sizes a system needs to handle. Why is that so important?
Because, a detector that's set up to catch a huge gasoline fire, that might not even register a small natural gas flame. They behave so differently. The heat signatures are different, how much radiation they put off, how fast they spread.
So you're not just adjusting sensitivity, you're basically teaching each detector what to look for.
Yeah, exactly. It's about fine-tuning things So they're sensitive enough to catch those small fires before they get out of hand,
Yeah.
but also not so sensitive that they're setting off alarms for, every little thing.
Right. You got to find that sweet spot. Our source gave an example, like a 32-inch natural gas flame versus a massive gasoline spill fire. Those need totally different settings to be detected properly. It's like calibrating a scale, got to get the units right.
Exactly.
And speaking of adjustments, something else that came up was how important it is to double check those detector settings, those coverage maps, after any changes are made at a site. Why is that ongoing evaluation so crucial?
Well, think about it. You've gone through all the trouble of positioning these detectors perfectly. They've got everything covered. But then, they add a new production line, move a storage tank. Suddenly your detectors might be pointing the wrong way or their view's blocked.
Or even just a small change, like, I don't know, they put up some new shiny surface that reflects light and boom, false alarm. Never thought of that.
Happens all the time. That's why it's so important to keep those settings updated, make sure the detectors are still calibrated for what's actually going on, and check those coverage maps regularly.
It's like regular maintenance on your car, right?
Yeah.
You don't wait until it breaks down to take it to the shop.
Exactly.
Okay, let's zoom out a bit, look at the bigger picture. How does flame detection fit into the overall scheme of industrial fire safety? Our source talked about the industrial fire and gas system, which sounds incredibly complex.
It can be. Basically, it's all these different systems working together to, detect fires, alert people, and then actually put the fire out. It's like a chain reaction.
Okay, I'm intrigued. Walk me through that chain reaction. What are the links in this chain?
So it all starts with detection. One of those detectors picks up on something, right? That signal, that's what triggers the system's operating logic, the brains of the whole operation. And the way that logic works, a lot of times they use what's called a cause and effect matrix. Basically, it's like a set of if this, then that statements that determine exactly what the system should do.
Cause and effect matrix, huh?
Yeah.
So how does that actually work? Give me an example.
Sure. So let's say a flame detector in, we'll call it zone 1, detects a fire. Then the system knows to sound the alarm in zone 1, shut off the fuel supply to that area, and maybe activate the sprinkler system.
So it's like a carefully planned out dance of safety protocols, all triggered by that initial detection.
That's a great way to put it. And it's not always the same response. It depends on what kind of hazard it is, what the facility's like. It might mean notifying people, setting off suppression systems, shutting down equipment, or, a combination of all those things.
Whatever it takes to contain that hazard, prevent damage, and most importantly, keep those workers safe. And to make sure these systems are really up to snuff, our source brought up performance testing, specifically mentioning FM, Factory Mutual. What's their role in all of this? Why are they so important?
Factory Mutual, they're like the gold standard, the independent auditors for this kind of stuff. They have incredibly strict testing, making sure every single detector is evaluated the same way, no matter who makes it.
So it eliminates any bias?
Exactly. And they use a standardized fuel and heptane. It burns really predictably, consistently. That way they can compare different technologies, different manufacturers, all on a level playing field.
So when you see that FM mark, you know that detector can take the heat.
That's what it means.
Man.
And even though N-heptane is the standard, some manufacturers will actually test their detectors on other fuels too, just to prove they work for more specialized applications, the really niche stuff.
So next time you see what looks like just a simple flame detector, remember it's just one small part of this whole system, all working behind the scenes to keep people safe in those high-risk environments. Really makes you appreciate the ingenuity, the technology, and all the thought that goes into it. And on that note, I think it's time we put out this deep dive. Thanks for exploring this with us. We'll catch you next time.